Okay, in this video, we're going to continue assignment 3, which is, I don't know, well, from my assignments, right? So we want to determine the global extreme values of the given surface, I guess, on the given domain. And we were supposed to not use calculus for this, so this one's maybe going to be kind of quick because we don't have to do any calculus on it. So let's see if that's true. This will be number 29. F of xy is x plus y. So my first thought is that is a plane. And so I think this will be easy because if you're sitting in a room and you look up, you will notice there's probably a ceiling, and the ceiling might be a plane. And depending on the room that you're in, that plane could be horizontal, but maybe that plane is tilted. And if the plane is tilted, meaning your ceiling is a little bit tilted, you'll notice that in one corner, it's the highest it can ever be. In another corner, it is the lowest it can ever be. That's what we need to figure out here. So we are restricted to 0 to 1 for x and 0 to 1 for y, which means we're over the unit square in the xy plane. So this is a plane, so we can definitely do this without calculus, or so I think. I'm going to try to graph this thing, right? So what I like to do is use maybe not intercepts so much as like I just need some points, right? Like I'm only allowed to go to 1 and 1. So 1, 1, and then let's say z is equal to 1. I don't really need that, but I do need that for like establishing heights, I guess. So when x is 1 and y is 0, z will be 1. So we're at the point 1, 0, 1. When y is 1, x is 0, z will be 1 also. So we'd be at the point 0, 1, 1. The origin, 0, 0, definitely gives us 0. And then if x and y are both 1, we will get z as 2. So we'll be like up here at 1, 1, 2. So I'm going to try to draw the plane. It's not going to look good. There we go. That's my plane. But you can see from the picture that the maximum on this, I guess, region, maximum over this region, is definitely 2. And it occurs at that point 1, 1. So our absolute maximum is 2. It occurs at 1, 1. The absolute minimum is definitely at the origin because we're restricted to this region. So the absolute minimum is 0, and that occurs at 0, 0. So we didn't need to use calculus. We just need to kind of think about it. So definitely recommended because the calculus that you have to do is worse than the thinking that you can do. All right, let's look at the other one that showed up here. So we have 32. F of xy is e to the negative x squared minus y squared. X squared plus y squared is less than or equal to 1. My first thought here is with all these x squareds, y squareds, I should just use polar coordinates. So I'm thinking of using polar, which would mean that x is our cosine, y is our sine, and x squared plus y squared is r squared. So we have this and this. So really, I'm not dealing with f of, well, I mean, I am dealing with f of xy, but I'm going to convert it to polar. I'm going to deal with f of r, a function of r, where f of r is just e to the negative r squared. So you can think this through and think like, if r is as small, like negative r squared is going to force e to the negative r squared to get smaller when negative r squared is bigger, like when r squared is bigger. All right, here's what I mean by this. Let's convert things. R is definitely less than or equal to 1, right? Because x squared plus y squared is r squared. So r is less than 1. Let's draw this. All right, so of all the things I can have here, if r gets bigger, e to the negative r squared gets smaller. That's what I'm talking about. So if r increases, e to the negative r squared, I forgot the squared, decreases. So the absolute max would be the smallest possible r value that I could have in this region. But keep in mind, we're squaring, so it doesn't matter if you consider negative r values, although really we just need to be between 0 and 1. So the maximum will definitely be when r is equal to 0. That's the biggest we could ever get. So I'm going to say that the absolute max is e to the 0, which is 1. That's the biggest you could ever get out of this function that we're dealing with. The absolute minimum will be when we take the biggest possible r value that we could have on this region, which would be r equals 1. So the absolute minimum is when r is 1, which means the absolute minimum is going to be e to the negative first. This one kind of, what does it remind me of? It kind of reminds me of like a big top, like at a circus, where you got that one giant tent pole in the center, and then it kind of like fans out away from it. You don't have to be able to imagine it to work it out, although it's definitely helpful. But anyway, I'm going to stop this here because the next type of questions that are in this assignment are slightly different. So I hope this was helpful and good luck.